exam. So make sure that we are memorizing our tests here. Make sure that we memorize our increasing, decreasing, what that means. That's super important so you can justify everything. Make sure that we memorize our first derivative test so that, again, we can justify everything super easily. Hello everybody and welcome to Cranky Calculus. We're here to talk about increasing, decreasing, and the first derivative test. We get to our first ability to really justify anything in calculus, and this can get very extraneous, so make sure that you're paying attention to the details. Do not forget to like and subscribe for more videos like this. And it's important too that you do download this free content in the description. You can get the notes and the keyed notes as well. So make sure you're paying attention as we go through this because this can get very technical. So let's get into it. So for increasing and decreasing on an interval in calculus, at least for AP calculus, they only care about the definition right there in the box. I'm going to go above and beyond because I want to make sure that I'm teaching you everything that's mathematically correct, not just what gets you points on the AP exam. So all this says for this increasing and decreasing on an interval for calculus here, that if f prime is positive, then the f is increasing on the interval. If f prime is negative, then f is going to be decreasing on the interval. I do like to include the endpoints as well because technically we can be increasing and decreasing at endpoints. So for example, if I have the function, I'm going to zoom in right here. If I have the function x cubed, that function is increasing on its entire interval because by the definition of increasing, decreasing, not the calculus version, but if every point after another point is larger, then we are increasing. So you can clearly tell that x cubed here is increasing. But if you notice in our definition, we don't include 0 whatsoever. So like what if f prime is equal to 0? So if f prime is equal to 0, that doesn't default it away from increasing. That doesn't get it away from decreasing either. What that does is we have to check if it's continuous or not on that 0. If we're continuous, then we can be increasing on the interval. Okay, so I will bring that all together here as I do this first example coming up right here. So we have this first example, we have f of x is going to be x times x minus 4 to the 1/3. Find the intervals in which f is increasing or decreasing. Explain your reasoning. So we need to first off find out what f prime is, set it equal to 0, find the critical points, make a sign chart. That's going to be new for us. We're going to be making sign charts here to find out when the derivative is positive and negative, and we can get to its behavior accordingly. So I'm going to find out what f prime of x is. So f prime of x is going to be product rule. So the derivative of the first here, which is x, is going to be 1. So it's going to be 1 times, leave the second, plus x. Now we're going to take the derivative of x minus 4 to the 1/3. This is a bit of chain rule. The derivative of the inside is just 1, so it actually can get away with not doing too much calculus here, but we're going to get 1/3 of x minus 4 to the negative 2/3. And we're going to want to set this equal to 0. Written as this is really tough to tell what the heck is this going to equal 0? So let's go ahead and factor, and hopefully we have some good factoring skills here. It is really important to know how to factor fractional exponents, especially if they're written out as like x plus or minus something. So we do have a GCF here. The GCF of the first two terms is going to be an x minus 4 because they both have an x minus 4 factor in there. Now I'll always use the smallest exponents for those. So this is going to be x minus 4 to the negative 2/3, and then that leaves me with x minus 4 to the first power plus looks like just an x over 3. Okay, we're going to set that equal to 0. What I'm going to do here is I'm going to do a lot of algebra to make sure I get this down to a ratio. Once it's in a ratio, it is super easy to do the sign chart and everything like that. So let's go ahead and get this into a nice looking ratio. So I'm going to have just this x minus 4 to the negative 2/3. I'm going to leave that for just a moment while I work inside of this x minus 4 plus, I'll just call this 1/3 x. If I were to add that together, I'm going to make everything inside that the bracket, the square brackets that I have there, I'm going to make everything over 3. So I'm going to x minus 4 to the negative 2/3. Make everything inside the square brackets over 3. So I'm going to get 3x minus 12 plus 1, and this is all over 1x. This is all over 3. So now I have my ratio almost ready to go here. I'm going to put x minus 4 to the negative 2/3 in the denominator where it belongs. You're negative, you belong on the bottom. So on the bottom here I have that 3, and then I have this x minus 4, making this now a positive 2/3. In the numerator there I have 4 x's. So I'm going to go, this is actually on the top right here, if you don't mind. That's 4x minus 12. I can actually factor out a 4, so it's going to be 4x minus 3, and this equals 0. So now I have this nice, pretty ratio ready to go. And I can go ahead and make a sign chart for that now. So I'm going to make a sign chart for that. I'll do that in green. So the sign chart, this is my f prime sign chart. Whenever you have this, you're going to find your 2 critical points. I have critical points here at 3 and at 4. How did that happen? Well, set the numerator equal to 0, you're going to get x equals 3. We set the denominator equal to 0, you're going to get x equals 4. Sometimes I can talk, sometimes I can't. Now, with these sign charts, I just look at the behavior of x. So the behavior of x is positive on the numerator and the denominator, so my right end behavior is positive. And then we're just going to look at the behavior at the zeros, see if we cross the x-axis or if we are tangent to the x-axis. So for the 4 factor, which is the denominator, we have x minus 4 to the 2/3. Since the numerator is even, this is going to bounce off the x-axis. So we're going to have no sign change right there. And x minus 3 has a factor of 1, not a factor of 1. It has a power, a degree of 1. So it's going to go through the x-axis. So we're going to cross, change signs. Okay, so that's my sign chart. Now I gotta figure out where I'm increasing and decreasing here. So f of x is decreasing on the interval from negative infinity until 3. Now, there's a big debate on whether we should include 3 or not. AP exam is cool with whatever. A lot of teachers just tell their kiddos, hey, don't include 3 because you don't have to worry about anything. I'm here to make sure that you learn math the correct way so that you can take this and go into the next level of math. I'm going to include that 3. Okay, this is totally okay in the AP exam. I'm going to justify it right here. So because f prime is negative, this right here as written will get you full credit on the AP exam. But if you want to be good little mathematicians, well, if we're including 3, that's not my definition. In order to include 3 for my definition, I mentioned it earlier. I didn't write it down. I did mention it though. Because we're continuous at 3. So because f prime is less than 0 and f is continuous at 3. How do I know it's continuous at 3? Because if you look at the original function there is no ratio to give us any type of holes, any type of vertical asymptotes. So I know that we're good to go as written. So if there's no ratio, you're mostly good to go with our continuity. Unless there's a piecewise function, that's going to mess some things up, but we're going to be good here. And then f is increasing on the interval from, I'm going to include 3, I'm going to include 4. Since I'm including 4, I'm just going to go right from 3 to infinity. Because f prime is positive and f is continuous at x equals 4. Again, this last part about continuity, I'm just trying to make sure they're doing the math correct. It's not required for AP exams, but it's required for you to be knowledgeable. Okay, so this is going to wrap up our first example. It is pretty loaded here. Make sure that we do explain the reasoning correctly. So that is going to wrap up our first problem, and let's go on to the next one, which is some trig. Let's see how we do on this one. Alright, so we're going to let h of x be x plus 2 cosine x, and we're going to do this between 0 and 2 pi, so we're bounded here. Find the intervals on which h is increasing or decreasing. Explain your reasoning. So here we go. So first thing I'm going to do here is I'm going to find h prime. I'm going to zoom in here. It's easy to write. So h prime of x is equal to 1, and then derivative of 2 cosine is going to be minus 2 sine of x. Set this equal to 0. This one doesn't have any ratio or anything. This is pretty straightforward. We're going to isolate sine of x. Let's go ahead and subtract 1 on both sides, and then we're going to divide by 2 here in a moment. So you're going to get negative 2 sine of x to equal negative 1. So sine of x, when we divide that negative 2 over, is going to give us 1/2. This is going to occur at x equals, now hopefully we know what you're going to circle. The sign is positive in the first and the second quadrants. So this is going to happen at x equals pi over 6. And 5 pi over 6. Alright, and then from here we can make our sign chart. So we have our sign chart here of h prime. And we're going to have, oh, actually, I'm going to give these things endpoints, not arrows, because we are just between 0 and 2 pi. So here's pi over 6, and here is 5 pi over 6. Okay, for this one, it kind of really helps to know what the hex sign looks like. This one, I can't do any of that fancy, like, I know what the end behavior is and everything. It's really nice to know what sign looks like. So with this right here, I know that the parent function for sine looks like this, between 0 and 2 pi, but what I'm happening here is I have a couple transformations. I'm actually going up 1, and I am, so the sinusoidal axis is here at 1, and my amplitude is going to be 2, so I go all the way up to 3, all the way down to -1, and this is actually a reflection, so I'm going to look like this. So because of this, I can tell that these zeros, I already found those zeros, they're going to be at pi over 6 and 5 pi over 6. So I'm going to go positive, negative, and positive. So I did that sign chart right there just by knowing what my sign functions look like. You could also just easily plug in these values into h prime of x. You can find out a value between 0 and pi over 6, like pi over 12, which is kind of difficult to find. If I like it easier to draw, you can find a value between pi over 6 and 5 pi over 6, such as, I don't know, pi over 2. Find a value after 5 pi over 6. But anyway, using the sign chart, I'm good to go. So h of x is, we'll do decreasing first. We are decreasing on the interval from pi over 6 until 5 pi over 6. H prime of x is less than 0, and h is continuous. H is continuous everywhere, by the way. So I can just say h because h is continuous. I can pick out the specific points, but this is actually continuous everywhere. And then we're going to do h of x is increasing on the interval. We're just going to go from 0 to pi over 6. And 5 pi over 6 and 2 pi. Because h prime of x is positive, remember write that, the inequality, and h is continuous. And I just add that last part so I can include the endpoints because, you know, I'm a good little mathematician, or at least I pretend to be. Alright, that's going to be our second example, and that's our justification. On now to our first derivative test. There we go, it's all on the screen now. So first derivative test is this. If we have a critical number c, again, we can find a critical number by seeing that the derivative is equal to 0 or undefined. So we have a critical number here. If that critical number, if f prime at that critical number changes from positive to negative, then we have a local maximum. If f prime changes from negative to positive, then we have a local minimum. If f prime does not change signs at all, then there is no local extrema. So pretty much, if we have for A, I'll underline this. If this changes from positive to negative, that just looks like this. So a positive increasing, then decreasing, right? That's going to give us a local max. Makes sense. And then if we are changing from negative to positive, that would be going, I'll draw it right here, purple. Okay, that's going from decreasing to increasing. So there you go. So we have g of x. Find the x values for of the local maximum and minimum point of g. So we're looking at the point, so we just actually care about the x values. I was going to say something else. So let's go ahead and find this derivative so we can find these critical values. So I'll do some blue. So g prime of x, this is quotient rule. So low d high minus high d low. So low derivative of the top one is just 1 minus high derivative of the bottom one is going to be 2x all over x squared plus 4 all squared. I will set this equal to 0. I do need to clean up this top part. I'm going to get x squared plus 4 minus 2x squared all over x squared plus 4. Set this equal to 0. Clean this numerator up. I'm going to go 4 minus x squared over x squared plus 4 all squared, which on the top is going to give me 2 minus x 2 plus x all over x squared plus 4. So critical points right now, when I set this equal to 0, this bottom will never equal 0, so that is totally fine. This top there will equal 0 at plus and minus 2. So I'm going to make my sign chart here for g at -2 and 2. This one is going to give me the numerator. By the way, the denominator is always positive, so like, don't have to worry about that. But the numerator is like a downward parabola. So a downward parabola has n behaviors that go negative outside of -2 and 2, and then we're positive, right? Because it kind of sort of look like that. So now, what's actually going on with g? I'll do this in red. What's actually going on with g? In g, we're decreasing, increasing, and then decreasing. And from there, you can kind of tell what everything is. And I don't want the x value. So this x value of x equals -2 is a local or relative, doesn't matter. It's asked for local stuff, so I'll do local. A local min, because g prime changes from negative to positive. And that's going to justify our local min. Okay? And then we have a local max here at x equals 2. So x equals 2 is a local max because g prime changes from positive to negative. It's super important to justify, and this is how you're going to get your max points when you take the AP exam. So make sure that we are memorizing our tests here. Make sure that we memorize our increasing, decreasing, what that means. That's super important so you can justify everything. Make sure that we memorize our first derivative test so that, again, we can justify everything super easily. That is going to wrap up our video here. Hopefully you learned something. Make sure that you like and subscribe.